Hi, welcome to Kagaku Library.
Hi, I'm Akari Kazuna.
Today, we are going to learn about atoms.
Atoms? I've heard of that.
The idea of atoms is the most basic of chemistry, so we start from this.
Isn't it difficult?
Not so difficult. Maybe.
Maybe.
Just kidding. Let's start to learn. Okay, now, I have the first question.
Question? I'm not quite sure about chemistry.
No problem. Please think as far as you know.
Okay.
This is the question. What is this world made up of?
What is this world made up of?
Yes.
Sweets?
Right, in a way. My question wasn't clear. I think you can find many kind of substances in your life. Metals, plastics and glasses. Clothes, flowers, water and animals. Do you think what are these made of?
No. That's too hard for me. I have no idea of that.
Actually, I know this is not easy. Because chemistry began to find out this.
Is that so? I think chemistry is the class that wearing a lab coat, mixing solutions and blowing up that.
That is so you, and I think certainly a part of chemistry. But today, I prepared this.
What's this?
This is a tumbler made of a metal. You can think, for example, this is made of copper.
When did you?
I made this secretly. Anyway, in around 1803, English scientist John Dalton proposed a theory that matter is composed of indivisible particles. The particle is called the atom, and the theory is called the atomic theory.
The atom and the atomic theory. Okay.
And this is the illustration of the atomic theory. When you magnify this tumbler, you will see something like particles.
Are these atoms?
Yes, these are the very atoms. This is a part of a theory Dalton confirmed in around 1803. I mean, the world is made up of atoms.
Is it the answer of the first question?
Right. This is an answer. From now on, we think every substance is made up of atoms. Because this is general thinking of chemistry.
Does that mean chemistry is atoms?
I think you can say that. That's how much atoms are important for chemistry. Please keep in mind we will treat substances the aggregate of atoms.
Okay, I'll remember that.
科学ライブラリー
The next is about the inside of an atom. It is known an atom has smaller particles in it.
I might know that.
Specifically, the particles are the proton, the neutron and the electron. Have you heard that?
Ah, yes. Doesn't that mean like Sunday, Monday and Tuesday?
Well, definitely no, unfortunately. Let's learn about the inside of an atom again. This is important too.
It might be good to study again.
This is the continuation of the previous image. And the inside of the atom is like this.
Maybe I've seen this before.
Did you? Then, pink one are protons, gray one are neutrons and blue one are electrons. And the proton is the particle that has a positive charge, the neutron has a neutral and the electron has a negative charge. Do you know atoms are composed of positive and negative charge?
I thought an atom is just the atom.
Well, when you see an atom from the outside, you can only see a mere particle. This is because in an atom, the number of protons equal to that of electrons. So, the total charge of an atom is neutral.
Does that mean an atom don't have neither positive or negative charge?
That's it. And one more thing, each particles have a place where them belongs.
Where? Sorry?
Them belongs. In short, it is the place drawing this image.
Well, okay.
Specifically, protons and neutrons are at the center of the atom, and compose of an atomic nucleus. Then, electrons are around of the nucleus. This is called the atomic structure.
I'm starting to figure out.
Since the words proton, neutron, atomic nucleus, and electron are the commonly used words, you should remember them.
Okay.
科学ライブラリー
An atomic nucleus has the inside story.
What is it?
Previously, scientists believed an atomic structure like this. Electrons being buried in a big positive charge.
What's this mean?
This means no atomic nucleus.
Is this serious?
Yes. But in 1911, Ernest Rutherford provided a new atomic structure.
Really?
It seems so. When his student irradiated alpha rays to thin gold foils, a big event happened. In the case no atomic nucleus, Rutherford thought all of alpha rays passed through the foil. However, in reality, look at this.
Wow. What's happening?
In reality, some of the alpha particles reflected and scattered various directions. This could only explain that the atom has a very small and heavy positive nucleus in it. Then from here, scientists got to believe the atomic nucleus is at the center of an atom, and electrons are around the nucleus.
I see.
When watched this result, Rutherford seemed to say,
If you fired a 15-inch shell at a piece of tissue paper and it came back and hit you.
with big surprise,
What?
nothing. By the way, according to a study, over 99.9% of the weight of an atom is that of the atomic nucleus.
Almost all the weight it is.
Right. The weight of the electrons is only 0.05%.
That's it?
Well. So when you calculate weight of the atom, you can ignore this weight.
Because is the weight of the electrons too light?
Yes, it is. And the sum of protons and neutrons in the atom is called the mass number. This is because the sum implies the weight of the atom.
Almost all the weight of the atom is the weight of the atomic nucleus. Got it.
For example, this atom has 2 protons and 2 neutrons. So the mass number of this atom is 4.
Does it mean the weight of this atom is 4 grams?
Close. We will learn about this at the topic of the atomic weight and the mole. At that time, I hope you'll learn the relationship, the mass number and the weight of atoms.
Okay, I'll try.
Well, that's all today.
Finally.
Today, we learned about the atom and the atomic structure.
I had many things I didn't know yet.
Okay, you should try to study step by step. Then, let's finish up.
Yes.
Thank you for watching this video.
Please looking forward next.
See you next time.